and welcome to all for this last session of the day, which is on the digital, which is the most hot topic and that talked about, how the oil and gas industry will get the value from. So today we have three presentations by our distinguished guests. I'll start with a short introduction. We have Valerie Panopio, Principal Solution Consultant, MSc of Spentech. Valerie is a Principal Solution Consultant at Spentech Technology based in the Singapore office. Her core focus is in dynamic optimization solutions and will work to position a vision and roadmap addressing customer requirements and identify differentiated value, including an implementation of the sustainment program of our dynamic optimization solutions. Prior to joining Spentech, Valerie was the business improvement lead at Shell Tabango Refinery in the Philippines with 14 years of experience in the optimization of refining margins and process operations. Valerie is an experienced professional in the oil and gas manufacturing industry with years of practice in refinery planning, scheduling, strong understanding of refinery process and economics, having delivered $10 million of annual optimization value for manufacturing, capable of communicating with stakeholders at various levels of the organization and very quick to adapt the changes and challenges in the workplace. Valerie holds a Bachelor of Science degree in Chemical Engineering from the Ateneo de Davao University in the Philippines. Welcome, Valerie.
Yep. Thanks, Manoj, and good evening, everyone.
We have another distinguished speaker, Mr. Juha. Mr. Juha is a Vice President, Regional Office, Cadmatic Software Solution, over 10 years of experience in Cadmatics, which is the leading software provider helping plant and refinery owners and operators, as well as EPCs and suppliers to digitalize their assets. Currently, he is in charge of operations in Russia, China, Middle East, India, and Southeast Asia, and is having the privilege to see how digitalization and digital revolution is proceeding at full speed around the world at the moment. Has been involved in numerous projects across the world and helped customers in streamlining their operations and taking full advantage of the vast number of possibilities that is offered by digitalization. Welcome, Mr. Juha.
Thank you, and good evening, everyone.
Another speaker for today is Mr. Sanjay Thakker, who is Director Refinery and Petrochemicals for Emerson Automation Solution India. He is having 20 plus years of rich domain experience and strong process knowledge in Indian refineries and petrochemical segment with strengths in capital projects, reliability, turnaround management, and strategy for building asset-intensive facilities. In his current role, Sanjay drives business in refinery and petrochemical vertical for Emerson. Welcome, Sanjay.
Thank you, Manoj, and good evening, everyone.
Another speaker today we have Nanda Kumar V. He is a Chief General Manager, Process Engineering and Production Planning, and he works for Mangalore Refineries and Petrochemical Limited. He has over 25 years of experience in oil refining. He has been working at Mangalore Refinery and Petrochemical Limited since 1993, presently heading the Process Engineering and Production Planning section of the organization. He has worked in production, process, and project departments and in refinery head office in various capacities. Closely associated with all the major milestones in the growth of the organization, he proved as a team player, team leader, strategist, and capable manager and administrator. Worked as a project manager handling 4 process unit projects, PFCCU, HGU, SRU, and ETP projects with a combined capex of $400 million, approximately 2,500 crore Indian rupees under MRPL's phase 3 expansion. Also worked as a team leader from process engineering or latest BS6 fuel quality implementation project and the refinery expansion studies. He is a member of PCD at BIS India and convener to the subcommittee 3-2 on aromatic hydrocarbons and petroleum solvent preservatives. He is also a member of the 3 expert panel members formed by Department of Chemical and Petrochemical, Ministry of Chemical and Fertilizer, Government of India for selecting and monitoring institutions under its Center of Excellence program. Mr. Nanda Kumar holds a degree Bachelor of Technology in Chemical Engineering from Government Engineering College, Thrissur, Calicut University, graduated with university first rank. He has also done a post-graduation certification program in management from TAPI Management Institute, Manipur. So welcome, Mr. Nanda Kumar.
Good evening. Thank you, Manoj.
So our first presentation, we will start from Ms. Valerie Panopio on digitalization in downstream and petrochemical to achieve carbon reduction and margin optimization. Over to Valerie.
All right. Okay. Do you see my screen now? All right. Yep. Okay. So thanks. Thank you, and good evening, everyone. My presentation tonight, I'll be talking about the strategic role of digital technologies in downstream and petrochemicals in achieving carbon reduction and margin optimization. So just a disclaimer on some of the topics that I may be presenting tonight, which may be part of possible future product developments. And any such information is just for discussion purposes only. Okay, so starting off with the decarbonization agenda. So basically, this is the biggest investment area at the moment for energy companies, and we've been seeing this trend in the recent years, and we expect this to continue in the next 10 or 20 years or so. And the top energy companies worldwide have been making aggressive commitments towards carbon reduction and sustainability, with the companies like Total, Shell, and BP making pronouncements that by 2050, they will achieve a net zero carbon impact on the environment. Even more aggressive in this side of the world, we have Reliance and Sinopec committing to a 2035 and 2030 achievement of the net zero carbon impact. And also companies like Lukoil pledging 33 million trees by 2025 to help achieve the decarbonization agenda in the world. The pressure is also felt in the financial industry, where you have the likes of JP Morgan and Chase establishing the Center for Carbon Transition, which aims to provide advice to investors and companies alike in terms of decision making to support the decarbonization agenda. So all in all, there is a lot of pressure that's driving our energy companies towards putting big investments to achieve sustainability and the decarbonization agenda. So the big picture currently is that the world is going through an energy transition, and that is the journey that we are taking towards achieving a net zero carbon impact on the environment by 2050. However, the reality remains to be that the world needs energy. And in fact, I'm showing you here the projection from the International Energy Agency, wherein in the next 10 years, we expect that much of the developing world is still increasing its demand for energy, while in the more mature and developed side of the world, we expect to see the demand for energy reducing. The unfortunate reality is that most of the consumers currently are still heavily reliant on hydrocarbon-based fuels, which, while very efficient and also cheap, has vast negative implications in terms of sustainability. Over the next 10 years, we expect to see an increase in consumption of renewable energy, but again, this doesn't come without any considerable investment. So it's not an easy solution. And that's just the reality that the world is facing at the moment. Having said that, we need energy, but unfortunately, the energy that we're using at the moment and we're producing at the moment is negatively impacting the environment, and basically how do we enable this the energy companies to achieve the promise of the net zero carbon emission by 2050. This is a study done by Konkawe in Europe, and basically what they did is they identified categories in the refineries where they can drive down carbon exposure and how much achieving that will cost. Identified categories are on process efficiency, renewables, and process redesign. However, in this current VUCA environment, where we want to achieve the highest impact at the lowest cost, the area where the greatest opportunity lies is across process efficiency, where we see optimizing process to use less energy, reduce carbon footprint and other emissions, and by doing that, a lower cost of production is attained. Based on our observation of the market, as well as what our customers have been doing, AspenTech views the sustainability drivers in the energy industry to be around resource efficiencies. So that's reducing usage of resources such as energy, water, or feedstock, and then of course the energy transition, moving towards renewable and sustainable energy sources. Circular economy, which is about waste reduction, recycling, and moving towards renewable feedstocks and more innovation. And of course, all of that is geared towards reducing waste and emissions in the energy industry. And AspenTech's digital solutions can help solve that sustainability challenge in these key areas. To accelerate the transition to sustainability, we see that digitalization will play a vital role. And as I mentioned earlier, the biggest opportunity lies in improving process efficiency. What I'm showing you here is the asset optimization digital reference architecture of AspenTech, which represents our vision of a holistic approach to asset optimization, and it's spanning the design, operation, and maintenance across the entire enterprise. So at the center, we have here the three core functions of operations, which is planning and scheduling, controlling and optimization, as well as monitor and execute. And this is the heart of production optimization. And our solution is, it enhances production optimization by leveraging on actual plant data via the plant digital twin to create more accurate planning by incorporating actual process conditions, as well as incorporating actual conditions of equipments and process by making the prescriptive maintenance information available for planning and scheduling as well. So cutting across all these processes is the value chain optimization, which connects outside the fence to optimize across the supply chain, from forecasting down to distribution and demand fulfillment. So this end-to-end process allows you to plan more holistically and better to meet the customer demands. Focusing on production optimization, our production optimization solution provides the ability to optimize from planning through execution, and it's geared towards reducing margin leakage in refining and petrochemicals. Okay, so basically margin leakage occurs in various levels of the production execution. It can be due to inaccurate planning models, unplanned downtime, losses, or any gaps between planning and operations, or it can be because units are not running against constraints. And traditionally, these various factors can be addressed in isolation. And of course, we expect that to result in improvement. But taken in isolation, we also expect that the gap, that the margin captured will not be close to the optimum plan, and there will be a gap in the margin that we are able to achieve. Okay, so AspenTech's production optimization solution addresses margin leakage by connecting all of the various business processes into a high-level integrated workflow. So what I'm showing you here is a typical workflow for a refining industry. So starting off on the planning and scheduling space, where you see planning and scheduling tightly linked, we are able to create more accurate plans by doing updates from simulation models that are calibrated by actual plant data via the plant digital twin. At the same time, information on prescriptive maintenance is also fed into the planning and scheduling tools to influence crude selection and asset utilization, further improving the value delivered for the refineries and the petrochemical plants. At the bottom, we have the monitor and execute layer, where integrated order management and execution, as well as yield accounting, ensures operation is capable of executing the schedule, as well as accounting for actual production and making sure that that is the basis for analysis of actual performance. At the heart of it all is control and optimize, where we have dynamic optimization as a key part of the production optimization solution. So AspenTech's GDOT optimizes a broad envelope in the refinery to coordinate multiple APCs and process units in real time to be able to achieve an adaptive closed loop optimization. All the while keeping in line with the planning and scheduling objective to maximize the best possible outcome for the refinery. Okay. So basically, our production optimization solution allows for synergies between various levels of production execution production execution from changing valve set points to long-term planning. And our production optimization solution is a proven solution that has delivered to the market, resulting to tens of millions of dollars of value per year, and maybe cycling back to my earlier point on process efficiency, production optimization also results in energy savings. So in plants, typically energy inefficiencies, of course, will result to margin loss. Excess energy use can contribute up to 30% of CO2 emissions produced in a refinery, which typically results about 10 to 15% of your margin penalties. The crude unit often wastes about upwards of 10% of energy, and even your supply chain inefficiencies, we expect about 1 to 2% of excess energy use. So AspenTech proposes solutions where technology can easily produce 15 to 20% energy use and CO2 emissions improvement. And with some targeted CapEx, we expect another 10 to 15% more savings to be delivered. So from designing heat integrated systems and process integrated strategies to applying advanced control to all energy consuming units, to looking at trends to come up with actionable improvements and ensuring accountability at all levels of the organization, as well as accurately measuring emissions and optimizing your utilities and energy use minute by minute. So our portfolio approach aims to achieve as much as 30% reduction in CO2 emissions towards the journey for sustainability. We have a few case studies here where we're sharing success stories from customers who have employed our solutions. So Repsol, for example, did an improvement on their petrochemical value chain, where they implemented integrated solution to address demand forecasting, supply planning, operational planning, and plant scheduling. So that's using Aspen PIMS AO, Aspen Plant Scheduler, and Aspen CDM to improve customer service, margins, and inventory. Dow Chemicals has achieved 700 million in cumulative benefits over 9 years. This is by increasing energy efficiency by 9% over 15 sites. So the solution we employed for Dow Chemicals is we started with their APC, where we commissioned DMC to help them adjust multiple variables and still meet their product demands. Later on, we employed digital twin optimization that improved their profitability. And because of the success of that project, they extended the deployment of the solution across 15 sites. Lastly, I have here Cepsa, who was able to reduce flaring by 72%. So that's an incredible amount of flaring reduction. They employed GDOT for their hydrogen optimization which included manipulation of steam reformer in 2011, and extended that optimization to their fuel oil blending system in 2016, and expanded the coverage to their entire hydrogen network in 2018. So currently, we're working with them and exploring optimizing their middle distillate area. In closing, AspenTech's mission is to work with our customers in accelerating the digital transformation, and we serve our customers by optimizing their assets to run safer, greener, longer, and faster. Yeah, that's my last slide. Thank you very much. Back to you, Manoj.
Thank you very much, Valerie, for giving us good insight, how to produce energy and chemical while consuming less. I think that's what I take, from your presentation, that how AspenTech is helping, using technology in optimization of the cost and energy. Thank you very much.
Thank you very much.
So now I invite Mr. Juna Asanti to share his vision.
Okay, thank you, Manoj. Just a second, I'll share my presentation. It should be visible now, right?
Yeah, you are. We can see.
Okay. Yeah. Thanks again, and again, good evening to you all. I'm going to talk about drawingless production in the digital and data-driven world, or more specifically in the process industry. How it looks at the moment, and especially when looking into the near future. So what's our let's say vision of it. So basically, what is this about? So process industries across the globe are currently undergoing a digital revolution that is creating and transforming business models. So they are increasingly embracing the vast number of possibilities offered by advanced digitalization in the plant engineering and construction lifecycle. So one interesting question is also that could these 3D models replace traditional design drawings, traditional 2D drawings? Question like this, so perhaps quite many would answer yes. But then the next question is that already, since the 3D models have been around and existing for nearly 50 years now. So is it so that this because 50 years has not been enough to polish the technology and replace old artifacts, such as these 2D drawings. And this Kondratiev's theory provides one explanation to this. Nikolai Kondratiev was a Russian economist who lived in the last century, and according to his waves theory, it provides a broad structure due to the history of technological development. Based on the financial data from rolling 10-year returns of Standard & Poor's top 500 companies, spikes and waves can be observed that match technological changes. So this picture here presents these waves along a timeline. What we can see is that behind every significant upswing in financial returns, which move the societal development forward, so there's a considerable step in the use of new technology. So first there was steam engines, railways, electricity, automobiles, petrochemicals, and IT, information technology. But none of these technologies is an isolated innovation or achievement. So it is something that a society was able to adapt and use for its profit. So technological breakthroughs are tightly linked to the societal development in terms of adaptation and acceptance. In other words, no matter how advanced or revolutionary technology you bring to the market, it won't break through unless it is accepted by the society. Following this theory framework, so the next and sixth wave of creative disruption will be fueled by intelligent technologies. There are many ongoing discussions in industry about digitalization, digital transformation, and digital manufacturing, industry 4.0 and smart factories, as well as AI and the use of digital twins in production. Intelligence is a key aspect of this sixth wave and differentiate it from its predecessor, which was based on information technology. So one can speculate whether this intelligence means actual artificial intelligence or the possibility to be not only digital but also data-driven. And digital twins are a good example, since digital twin is a digital representation of an object enriched with behavioral models and configurations and conditions. The novelty of digital twins is not the existence of and the use of 3D models as assets, but how these models are bundled. So in other words, it's not about IT anymore. It's not about the possibility to digitalize all the data and 3D model, but about intelligence behind this data. And the intelligence of IT enables improved usage of data in digital format that is suitable for production. For example, based on the data collected by Cadmatic. So when the first 3D viewer, which was and is called e-browser, was introduced on the market a bit more than 20 years ago. The direct estimation from the clients was that they were able to reduce the number of drawings needed for production by as much as 30%. So, and therefore the 3D model became accessible not only to CAD users, which are typically in the office, or the typical designers which are in the office, but also production people. And it also did not require any special skills, trainings, and these kind of things, and therefore provided a powerful push to reduce the number of drawings. However, there are still cases when the amount and types of production drawings are more justified by tradition and processes at clients, and less by the practical need for these drawings and production. Following this development, after introducing Cadmatic's eShare as a central portal for all interlinked project information, a further reduction of the 70% of drawings was achieved. So this is only one example where increased intelligence in IT technology significantly affected the number of and types of drawings involved in production, but was capped by societal readiness to change the existing methods. Pioneering companies focused on innovation and effectiveness were more ready to make this change than the ones where tradition and maintaining the status quo were stronger driving forces. The human and societal factors conflict with technological possibilities in this case. And also, as a last point here, so the level of automation is the key dimension in the discussion about automated production. There are many possibilities to automate production: steel cutting and bending, welding, robotics, 3D printing, and automatic adjustment for workshop flows based on data analysis. Together with developments in robotics, this has become an essential factor for manufacturing. So what about the future of drawingless production? Well, considering the main driver of intelligent IT, drawings are already being gradually substituted with 3D viewers and with direct data transfer to production or manufacturing control system. And here CAD plays a key role in the substitution process by providing interactivity with data and faster access to it within change management. Original input to CAD was provided by users. However, this is slowly changing towards the use of embedded design rules and substitution of direct parameter inputs with inputs based on analysis or artificial intelligence. An interaction with data distinctly differentiates digital era. The first attempts to standardize drawings aim to improve readability and production quality. For the data native generation, this poses unnatural limitations. So instead of static snapshots, so people prefer to obtain data on demand or on the fly and then manipulate it. All alternatively use VR, virtual reality technology, to position oneself in the future industrial facility. This is where Cadmatic easier type of application, for example, becomes vital with its capabilities of managing huge amount of data real time. So as a conclusion, I could say that change from traditional drawings into drawingless production is happening already and technique is available. However, this change is gradual and it's more a question of societal adaptation and acceptance than technology. Yet it is quite obvious that those companies ready to innovate and take the advantage of available technologies will outperform the ones stick to existing traditional methods. So basically, that was all I wanted to say about the topic. So thank you.
Yeah, thank you, Mr. Juha. I think you have given the good insight that the drawingless production, and I tend to agree that the technology techniques are available. It's a matter of adoption. What we need to, what industry need to look into. Thank you very much for good insight. And now we have Mr. Sanjay Thakker, who is representing Emerson, to give the insight on addressing process upsets in refineries and petrochemical units using data analytics. Over to you, Sanjay.
Is it visible, Manoj?
Yes, Sanjay, we can see.
Yeah, thank you very much. Thank you very much. Good evening, ladies and gentlemen. Welcome to a session on digitalization, and where today I will be talking about addressing the process upsets in a refinery or petrochemical units using the data analysis. As the industry knows, Emerson is a leading process technology solution provider with solutions ranging from sensors to boardroom. Let's see how the technology has evolved. We all started the process industry with pneumatic instruments, where the whole thing was on the OT and IT. There were two domains that were completely different and virtually working in a watertight compartments. Although we started pneumatic, but today, if you see the advent of smart sensors, the moment it started, the whole OT world started to opening up, and connectivity with the IT things. We started talking about how to connect it with the IT and how we have the best of both the IT and OT world. And today we see where we are, and rest is all a history. Today we see a seamless integration of IT and OT world, enabling data flow right from sensors to boardroom, virtually on a real-time basis. We have seen that the whole thing, initially whole thing started with the diagnostic smart devices started coming in. Then people thought of putting in some kind of analytics so that a ready-made template is available. Emerson also started offering solutions for the process to handle the process analytics or the equipment analytics. So it all started with a simple template-based kind of thing, which cannot be configured for a particular plant or asset. Next came to the first principle analytics, where we started customizing it based on the plant data for a particular equipment or for a particular plant. And today what we are talking and we are looking at the world is where it is about the advanced analytics, where we do the root cause analysis, where we do the complete anomaly detection, machine learning, the event detections. All these things are possible today with the data science and the analytics. So this is the domain which we are going to focus on today. The Emerson offering, which comes in the form of a platform, we call it a KNet or a knowledge net. We all have seen every refinery or a petrochemical unit has got a lot of data available in terms of history. People boast of we have 10 years data or 5 years data, but do we have the actionable insight out of that data? That's where the question remained. All kinds of platforms are available to historize, call it PhD, call it OSIPI. Yes, all those solutions are available to the industry. But with the advent of data analytics, what is coming out is the actionable insights. We have the real-time data from alarms, data sheets, historical data, process flow diagrams, FMEA models. Everything today can be really fed to this kind of models, be it from Emerson, be it from anybody. But what we are talking here, discussing here is the basic, how really the whole industry, how the data analytics industry is maturing. We call it machine learning today. Yes, it can be done offline. If we have the offline data, there are techniques available for cleansing the data or clustering using the principal component analysis or decision tree or regression models, which can be fed to the online data also. So we can use either offline data or online data, and the whole thing can be deployed to really getting the solution. So the uniqueness which is coming out of today's mature platforms is that the same platform can be developed. The KNet can be really used for multiple applications. The same platform, once deployed, can be used for asset health management, or to really detect the performance gaps in the operational or the energy. Any application you think of, the problem statements we have, using the data analytics of today's technology, yes, it can be solved. It can help us in predicting the failures beforehand, really before we really get to the failure mode, beforehand we may have. We can identify the root cause. As we go through the presentation, we'll see that how exactly it helps us. It also tells us about the corrective actions or the prescription, which we call it today, the corrective actions to be taken. A prescriptive model is available. Of course, dashboarding has become very, very smart in today's world. So all these applications do provide us the smart dashboards. So using these solutions, what is coming out is the process insights, the operating envelopes of the process. We have the predictive models, And even the soft sensors can be developed and deployed to really get into the process insights. We have deployed these solutions in various industries for various reasons. Like we have a customer who has used it exclusively for energy optimization. The same platform has helped us achieve phenomenal energy savings. So these kind of things are available, which can be deployed easily on these solutions. Another is the process application, and third is the asset health management. So the same platform can be deployed, can be used for many, and these are just the three which I have listed here. But the same platform can be really deployed to many applications we are facing in today's refining or the ever increasing complex petrochemical world, I will say. So today, since we have chosen it to talking about the refining and petrochemicals and the process upsets, so let's have a deep dive into the process application, one of the process applications, I would say. So we have chosen a very simple example today to really talk about in terms of a very simple example of distillation column flooding, where it can really lead to the liquid entrapment, can really may lead to damage of trays, and of course the loss of separation, the off-spec products, efficiency, dropping of efficiencies, and the reduced product yields. So these are the common problems if we have the distillation flooding. So how can we really predict beforehand before it goes into it? And what are the challenges to really identify that the flooding is really going to happen? So the first thing is to really efforts required to diagnose the flooding. Yes, it is costly in time. By the time we really detect that we are getting into a flooding zone, we might have lost in terms of production or in terms of yields or in terms of energy. Yes. Second is the gaps in the knowledge and the expertise. So it becomes person to person. Now, how can we really reduce the subjectivity, whether the good people or a super intelligent person available in the plant? How really we can reduce this gaps in terms of handling of the situation of the abnormal conditions. So this kind of models can help us in timely predicting the right thing. There is no chance of misdiagnosing, I will say, because somebody may predict it as there is some problem in the downstream or the upstream. But how do we know that yes, exactly there is a flooding, and we know that any downtime because of flooding can get into a very if it goes into a damaging of the tray, that can be very expensive. So the refinery which I'm talking of, we talk to them and really to what exactly is they're looking for. Why
we are losing you in between. If you can come nearer to your laptop or iPad, whatever you are using.
Okay. So are you finding it less volume?
Yeah, in between,
Okay, sure. I will try to be closer to the mic. Yeah. Okay, so thank you, Manoj. So now what is the objective of our deploying these solutions is, yes, we want to maximize the tower performance, isolate the root cause immediately before it really starts hampering the operation of the unit, timely detect and predict the upsets before it really starts, and we are getting into that zone. We are told about that, yes, you are getting into that zone. So it helps us in really shortening the problem to resolution cycle. And the best part, which really we feel in today's world, is that the mobility of the people have really increased. So if we really need to retain or capture, I will say, the knowledge. These models are basically in terms of maturity. They mature over a period of time. Once deployed, they mature over a period of time, and everyone plays a role. All the critical people who are involved, they play a role in maturing the model. So how do we capture those things? Even if the person leaves, the model is mature enough, and we have really captured all the knowledge which can be used across the organizations. So these were the main objectives when we really deployed the solutions. I'm just touching upon one of the component on really how the data modeling is helping us to detect the anomalies before it gets into it. We can see that maybe I'm operating in mode 1 or a mode 2 kind of things, but I know we can really detect where is the abnormal mode which is really going to affect my operation. have we really gone into these abnormal zones? Humanly, virtually, it is impossible to analyze so much data. The operation guy comes in a shift and goes back. So really, nobody knows the entire thing. But if we have this kind of data analytics model, which is monitoring the entire process 24 hours a day, maybe for a longer period of time. Say I want to detect the degradation in the catalyst. Say we have deployed the same solution in degradation of catalyst. So maybe over a period of 2 years, we have the data. Somebody who is watching the data model, which is watching continuously and analyzing it, that yes, there is something, and giving a prescription. So this is the model which we are talking of in terms of how it can help us. So this is the kind of dashboards we have today. If we talk of one of the refineries where this tower flooding solution has been deployed, we can see that we know how much is the flooding rate in the overhead or the bottom. What is the recovery rates I'm getting in terms of what are the KPIs along with the time step when the whole thing is started. Even these models helps us in identifying what is the best ever which is achieved. So what is the target minimum or target maximum? In Emerson modeling, we call it dynamic targeting, which I will touch upon slightly later. So we know that where are we? Are we in a red zone? Are we in a green zone currently? When all the whole things are started, what are the KPIs? So we have a dashboards available to help monitor the things on a real-time basis based on all the historical analysis. The second most important part is, again, this model also keeps on maturing, is the fault tree analysis for the RCA. We can see that it can really help us in identifying that what are when the flooding is started, what are the reasons, what are the possible causes. Everything in this model can keep on expanding, keep on maturing over a period of time. The way we develop, the kind of problems we face, and the kind of analysis we do, we keep on maturing this model. So we have everything is retained in the database, irrespective of the person who has analyzed, is there with the company or he has left the company, everything. So this is something which I was talking about, the dynamic targeting. It really takes into account. Suppose pump A or pump B is running. So now pump A has got a more efficiency, we know it, but it's not available. So it actually tells us, based on equipment ability, what is the target? Where are we and what best can be achieved? How close are we to those KPIs based on the best ever possible? And it keeps on increasing. Today, I have I'm operating with the efficiency of 78 or 80%. Tomorrow, the best ever achieved is 82. So it will always tell me that best ever achieved is 82 and currently I'm operating at 80. So these kind of things can be really help us on a real-time basis to always, somebody is watching and somebody is guiding to help us, I will say that rather than watching. They're always guiding us. We are always guided to really operate the plant. So depending upon all the process scenarios or the best performance or the equipment availabilities, we really know the target and how far or near to the target we are operating. So the overall approach which we took for this particular refinery was that all the data sheets, all the manuals, everything was really mapped into a digital tower assistant, which we call it. And there was a KNet engine, which was really working behind and helping us in really getting into the actionable knowledge, or what all possible things in terms of flooding was really identified. We can have the performance insights and a very intuitive visualization which can be understood by anybody. So this is the advantage we have with this kind of data analytics. So these were the key performance indicators, that is performance, energy, production, efficiency. So what all is there? Everything is mapped and modeled for that particular thing. So analytical models were prepared based on dynamic thresholds, baselines were defined, what all is there, what all assets are participating in this particular event kind of thing, I will say at this stage, and what all events could have happened. So there can be liquid entrainments or tree damage. So everything we can really, with the tower flooding application, we can identify. So that is the main idea behind the whole thing. So when I say the whole, if I want to sum up, the KNet analytical model it has got a built-in intelligent KPIs management, the asset failures prediction. It can be deployed to rotary, it can be static. It can be like rotary, of course, vibration, and all those things can be really predicted. Or in terms of failures, if we are looking at the corrosion rates for the static failures, those also can be monitored deploying the same assets. We know that how long we can defer the shutdowns, or how the performance is right now, or what is the allowable performance I can operate till going ahead and avoid shutdowns or defer shutdowns. So experts, rules, and complex events can be built into it. And the best part is that there is an automated root cause analysis. Corrective actions in line with the best practices are available to the operator in terms of prescriptive analytics, what we call it. So instead of preventive or those kind of things, we have a prescriptive things available to be really what actions we need to really take to make the plant efficiencies. So what I'm in the sum up, what I would like to say is this is the one platform kind of thing which can be deployed. Your goals can be different. It could be energy management. It could be asset improvement, or it could be even production efficiencies or production optimizing the plant. So for all these things, we have single solution, and any complex events or event can be detected before really it starts sampling our production, and it can have a damage to the plant. That's all from my side for data analytics. Manoj, I think I'm on time. Thank you very much. Thank you, everyone.
Sanjay, thank you very much, to give us the good insight where everybody's talking, okay, data is the new oil, how data can help, especially on, the asset optimization, I think it was a good insight for all of us. Thank you very much, Sanjay.
Thank you, Manoj. Thank you. Thank you.
So, Mr. Nandakumar, you want to conclude, or want to say the final remark?
Yes, Manoj. It was very interesting session we had with three different.
Sir, can I request you to adjust your camera slightly so we can see your face?
Okay.
Thank you.
Yeah, what we are trying is these speakers touch the problem from three different angles, I would say. Like digitization, Valerie started with the digital twin of the complex and tried to optimize or maximize the asset efficiencies, basically process efficiency. And Juna Asanti started, narrated his perspective of from drawingless, how the 3D model itself can, convert into the information and the data on demand. That's a concept he was, proposing. And last but not the least, Mr. Thakker came with a new, very revolutionary tool which helps all the plant managers, irrespective of which industry. This happens to be refining conference, fine, but I'm sure that it will go to any process industry for that matter, where the key thing of what I understood is that he's talking about gathering the knowledge within the system, using the tools, and evolve the model on the fly, eventually which will help the plant managers to reach the solution what they were looking for. So that's kind of very interesting. So this is a very, very interesting sessions. And from my point of view, what I would start is this digitization should, or rather sitting on a premise that apart from the other assets of, I would say a refinery, for example, the biggest asset we are ignorant of is the data. I'm sure, the day we started the digital DCS control system, maybe early 90s when I started my career, from that day onwards, enormous data have been collected, but sat unused. Basically, we ignored the biggest asset we ever had. So that probably, would be the focus of the digitization. How to, like any asset, focus should be to how to monetize the asset, how to make value out of the asset. And I'm sure the tools proposed by Mr. Thakker or Valerie or Mr. Asanti would help in reaching this objective. It's a whole picture, but they are trying from different angles. They are approaching the scenario. So we have tool sets, and the culture of handling the data, treating the data, and looking into the data. So that is the most important change we needed. Like today we are talking about Internet of Things with embedded intelligence. People are talking about that level also. So ultimately, the intelligence should be put to use. Otherwise, like many other assets, we'll have one more asset sitting idle. And the present focus is to decarbonize the industry. Being hydrocarbon industry, we should not be talking like that, because our entire thing comes from converting crude oil and making other people use it as a fuel. That apart, but there are tectonic shifts happening from the fuel perspective. We are talking about manufacturing petrochemical, which are not, they are like lifestyle chemicals or lifestyle materials. They are not entirely end up in like burning in and converting it into carbon dioxide or water molecules. The ultimate product of hydrocarbon, burning it. We are talking about making materials. So the core aspect of our industry should be converting the carbon molecules into something else. And I'm sure the energy efficiency or the process efficiency management, which Valerie talked, or the dynamic intelligence which we were to develop in the operation, like Sanjay told, or the concept of the creation of all these concepts, how to capture it as 3D models, like you have told about this Cadmatic tool. So all these coming, like fitting pieces in a jigsaw puzzle. So I think this is a starting point, and we can take it up further from this initiation point. And I compliment all the speakers. Thank you for all your efforts. And Mavis, it's a very good effort from Chemtech. And Manoj, thank you for
Thank you, sir.
Handling the session. Thank you very much.
So we now move on to the question and answer session. Manoj?
Yeah, thank you, Mr. Kumar. To summarize well, what all our speakers have, spoken. And I agree with you, where the biggest assets, what we had been collecting, over a period of time was ignored, and especially in the refinery sector. And I think the time has come where everybody started looking into and how to monetize, this biggest assets. I think, we all are on that journey. So now we are open for any, question and answer. And I guess we have few questions. The first question is for Valerie. The question is, does you look into equipment limitation when you're looking at the optimization of the plant?
Yes, yeah. Should I answer this question first? Okay.
Yeah. Okay. So the question is, this is the first question, that does it, you look into the equipment limitation when you're looking at the optimization of the plant? And second is, what kind of a payback period, user is looking at when embark on this optimization journey?
Yeah. Okay. Thanks for that question. So yes, so definitely production equipment limitation is taken into account in the whole production optimization process. So as I mentioned earlier, dynamic optimization is very closely linked and works within the sphere of the planning and scheduling constraints. So the inputs that dynamic optimization takes into consideration is coming from planning and scheduling, which is made accurate by inputs coming from the digital twin. And at the same time, dynamic optimization forms a closed loop optimization with the APC of different units. So actual plant conditions, CVs and MVs are communicated to the dynamic optimization system and is taken into account in the optimization of the entire envelope. As for the payback, it really depends on the scope that you want to optimize. So you want to optimize a very small single unit portion of the plant, or the entire middle distillate production envelope. And how AspenTech deploys the production optimization solution is we can do that in phases to reduce the time to benefit. So it can be anywhere from maybe a year or longer, depending on how big the scope you want to optimize.
Okay.
Yeah.
Thank you, Valerie. And just from my curiosity, Valerie, let's say when you start optimization journey, so if you suggest to go by each unit, or or you suggest to go by entire complex in one go?
Well, what we normally do is we work closely with the customer to identify where the value is sitting. So we identify where is the typical source of leakage for the refinery. Ideally, the value of dynamic optimization is seen when you deploy it end to end, like for a whole aromatics envelope or hydrogen envelope. But as I mentioned, we can do chop that further into phases to reduce the time to benefit. So it really the what will drive the implementation is where the most value is sitting. So we pick out the quick wins and then we go from there.
Thank you very much, Valerie.
Yep.
So another question is, what will be the challenges and advancement expected in the next 25 years? Next 25 years is a long time in this petrochemical industry with respect to AI, ML technologies. So maybe Sanjay, you want to answer that?
Oh, 25 years is a pretty long time, and by that time, I don't see any fuel we will be selling. Every molecule will get converted. The crude to chemical will become probably today we are talking of maybe Nanda Kumar ji can help me, maybe 40%. That is the maximum possible today to petrochemicals. Maybe 25 years down the line, I don't see any gasoline or HSD we are talking of. And I will not be surprised even aircraft speed, they're talking of solar and all those kind of things. So we don't know, 25 years is a long time. But if you see the value chain, yes, there will be ever increasing deployment of AI and ML. AI and ML is nothing but basically the usage of the data analytics. Nothing, it's all depend, whatever data you have, how really you are converting it into actionable insights. That's where the you call it artificial intelligence. ML is, I see it as ML is just one of the applications of artificial intelligence. So yes, it is because these are getting more and more asset intensive. If you see in Indian context, if you see the IPCL when it started, the kind of capacities, and today the HMEL what they are getting into the petrochemical complex. Probably 10 IPCLs are coming in one plant, one complex. The kind of energy, the kind of compressor, say, when I started hydrocracker, 1 megawatt compressor was a big thing. And when we used to start, we used to call up power plant at, okay, young man, I'm going to start 1 megawatt machine. Please take care. And imagine today a 40 or 50 megawatt machine is being deployed in a refinery. So yes, we with ever increasing complexity, even during my presentation, I use this word, the petrochemical world. It is the petrochemical world which is getting into more exciting phase. Refinery, fuel, whatever you call it, the crude is going to down. So we see a bigger opportunities in these. The moment complexity increases, yes, the deployment of the tools and human brain becomes limited to analyze that data with one brain kind of things. So yes, we see a lot of opportunities in petrochemicals, especially petrochemicals industry, we'll say.
I mentioned Sanjay, and in my perspective, the biggest challenge is there is no limitation in the technology. Technology is already at advanced. I think the adoption of state of business is going to be a challenge for years to come. Okay, so the next question is, how about cybersecurity? How do you prevent data from getting hacked? It's open for anyone.
So Manoj, I will say you are the best person to respond to it.
Okay, so from my perspective, if we try to retrofit the cybersecurity, okay, it would be a big problem. The cybersecurity should be by design. Whenever any project is getting implemented, it should be by design. The cybersecurity should be. And I would say, the IT is being matured, okay, because a lot of attention was there on the cybersecurity side in the IT, but we have been ignoring the operation technology from the cyber part. So right from the design where IT, OT integration, we are putting a lot of sensors and, opening various firewalls to, the access of the OT data into the IT network. The lot attention is required towards the operation technology, whether it is the patching of the servers, operating system, etc., etc. Many things needs to be done. And prevent data from getting hacked, nobody can guarantee, nothing will happen. You can do best what is available. And if somebody says, there is a guarantee, etc., nobody in this world can give you the guarantee. So the message from my side would be, it should, instead of, retrofitting, it should be by design.
Yes, I can add to that, Manoj. Basically, a system is strong up to its weakest link. So, generally, we have seen IT part, the hardware, the software, everything will be taken care. Typically, the weakest link will be the operator, the person who is going to handle all these things. If he inserts an unauthorized, memory drive, and that's it. That's enough to sabotage the entire work, which we have seen. It happens in various places. So, the human aspect also to be factored when we talk about.
Yeah, absolutely.
Most likely, an insider attack is the most difficult part to handle it.
So we can sum up as it's a journey. There is no destination to have really the cybersecurity that I am always protected. Now there is no destination. No, it's a
journey. Yeah, correct. So the next question: what are the challenges? When implementing data analytics for a refinery? Sanjay, you want to answer?
Yeah, that's fine. Me or Valerie, anybody can answer. So that's fine. Let me take it. So the challenges in today, if you see in today's world, after the openness of the OT world, I will say the challenges have reduced. Earlier, it used to be a very proprietary kind of systems, and really those connectors were not open. If you ask me today, virtually the industry is moving towards plug and play in terms of connectors. Today you take any data analytics platform, they are compatible to and easily connected to any of the service providers, historian, or whatever data source, LIMS, whatever you want to bring in. Today it is almost like a plug and play kind of things. It has reduced the challenges in terms of connectivity. So that way, in terms of connectivity, we don't see a big challenge. The challenge remains I come to those days. See, remember the DCS days when we started. I'm a man from pneumatic to electronic to today we are talking of analytics. So my first plant was a pneumatic plant. So a DCS training used to be 15 days training and intensive sessions. Today we see hardly 4 days DCS training. And that too, the whole thing has become so simple. I am looking at, yes, today there are complexities. I don't say, yes, we need to really train the people, but once trained, these are deployed. People are moving towards template kind of things. People are, all the suppliers of this technology are moving towards template based kind of thing. We also have many modules which are available. Just you can bring in like a boiler, but then, yes, it's a moving. So yes, there are challenges in terms of resources, which I see as a big challenge, who can really help us in quick deployment. And of course, historians are nowadays data, as you said, tons and tons of data. Nandakumarji rightly said, tons and tons of data is available in a refinery. So that is not a challenge nowadays. Only thing is the human resource, which we really see as a big challenge in today's world. Yeah. Maybe Valerie would like to add.
Yeah, I think it's the same. I share the same opinion where all the data is readily available, and technology has advanced so much that you can just pull all this information in a quick snap of a finger, and the hurdle we always encounter is sourcing the people who will be there during the deployment. But I think after you have deployed, it's smooth sailing from there.
So it's a related question. I don't know whether somebody can answer this. What size of manpower is needed to monitor these data? Example, a refinery. So again, it's a very subjective question. Somebody really needs to look into what kind of a solution, what kind of a monitoring you need to include. Maybe Nandakumar, you want to answer on that?
Yeah. What I would suggest is you don't want to a separate group of manpower to handle the data. Basically, the existing the technical services or the process engineering division reskill if needed to take care of this data aspect. Generally, the younger generation, as Sanjay said, they are quite comfortable. We started with, as you said, pneumatic, or you have even seen the floppy disk kind of computers. Now, this will be quite relics if you talk to these younger generations. So obviously, it is a skilling or reskilling. So the company or the organization should have got a policy and definitive procedures to reskill on a periodic. After a technology scouting, they say the coming up technologies are a skill needed to handle these technologies are XYZ. Then get into the training mode and get the personnel enable themselves to do such things. Of course, there are specialized services are maybe needed, and that's where we have the people like Larry or Sanjay. They will handle of those special. That's my take.
Okay. So another question we have for Mr. Juha, but I guess with Mr. Juha, there is an audio problem. Juha, can you hear us now, or still you're facing some problem? So I think, the audio problem still exists with
Still
Juha.
exists, yes.
So,
but he has replied on the chat because I placed the questions on chat.
okay.
So he has replied on chat and I can read it out if required.
So the question is, what is your Cadmatic service to digitization, digital twin and plant BIM technology in global process industry and also in India process plant industry?
Okay. So he says Cadmatic services to digitalization or digital twin and plant BMI technology in global process industry and also in Indian process plant industry. The answer is that providing a software and services covering the whole life cycle of a plant from initial design through construction up to maintenance. So design applications as well as information and operation management.
Okay. So I guess we have covered all the questions and we are dot on time.
Also, about cybersecurity, that is topmost priority in all software development. In that field, the biggest risk factor is the people in the organization and not the technology. What he has to say.
Okay.
Correct? And regarding the question about AIML, he says the top problem are the old habits and willingness to adapt to new processes and technologies. Many companies are afraid of testing it out. So these are the answers, responses that we received from Juha. Juha has joined back again. Juha, are you able to hear us now? Juha?
Yes, now I can hear you again.
Yes,
Yeah.
Finally.
Yes.
Okay, and we can see you too.
Yes,
So I just read out the responses to the questions that I had placed to you on the chat.
Okay.
Let me check if there are.
We do not have any further questions, and it's 8 p.m. Presentation and the questions.
They're shutting exactly on time this time.
On time, yeah.
Because we have the best moderator in Mr. Manoj Kumar, all the hard work and doing all the work for me also. So thank you so much, Manoj, for joining us this evening, and also Mr. Nandakumar. I would also like to thank Valerie, Mr. Sanjay Thakker, and Juha for joining us. Also, Stephanie for being there to support us. Thank you so much. And with this, we end the Refining and Petrochemicals World IE 2021. This was the second day of the session, so we complete our session today. Thank you so much for joining us.
Thank you.
And
Thank you. It was
hopefully
nice.
Hopefully, we will meet next year in person and not virtually like this. Right, Mr. Thakker?
Yes, we are hopeful.
Thank you so much.
Have a nice evening to all.
Thank you. Thank you very much for this opportunity.
Thank you very much.